Good day, this tutorial is our first in a series of tutorials that will look at the BananoServer, a Java Jetty web server implementation, using the Banano library by all-in. To make this efficient, we have created a configuration file that will keep a record of all settings for our app. This has our app settings like the application name, the port the app will run from, and some settings that the Banano library uses. For example, the upload max size specifies the maximum allowable file size to upload per file. When the application starts, this configuration file is read. So each server app needs to be ran from a different port, for example. Then you will update the configuration file to indicate such details. BananoServer expects two modules that are mandatory. This is the server module and the browser module. These handlers ensure that your BananoServer app works as expected. Also, a shared module is needed for source code that will be shared between the browser and the server backend. The browser module has Banano-specific source code, whilst the server module has B4J-specific code. The shared module can have both. As this is a B4J project, we are using some B4J-specific libraries, for example JSON, encryption, etc. For our user interface, we use Vue.js and Vuetify. For this example, we are using SQLite as a backend database. We have created this database in our files. It has a single table and we will add, update, delete, and get records from it. The database has a user table. This has three fields: ID, name, and age. You will remember this from our previous PHP-based examples. For the BananoServer, we are not using PHP but the SQLite library. We have created the server handler. This will run our B4J code. The browser handler will manage our browser-based code. The server handler uses WebSockets, so each time a connection is made, the WebSocket connected code will be executed. To be able to speak to the SQLite DB, we have created a subroutine named SQLite onServer. We call this via WebSockets as a promise to execute any server-based source queries to the database and return JSON result. For this to work, we have created a shared code module. This shared module links the browser part of the app with the backend database. This shared code module can contain both Banano, that is, browser code, and B4J, that is, Jetty web server source code. We have named this module Shared ODBC as it is the link to the backend databases. We have our Open SQLite call that opens our SQLite database. You will recall this from any B4J project you might have done. As this is a B4J specific call, we enclose it inside a if B4J directive. The to JSON method receives our payload, gets the query and arguments, and execute a query against the backend database. This is also a B4J directive-based call. When this sub is done, it returns a JSON payload that is later received by the browser. This always returns an affected rows of -1 when an error happens. As indicated, SQLite onServer gets executed on the server via a promise-based call. It will return a JSON payload to be accepted and processed on the browser side. The browser handler is where our user interface will be created. This is done when a WebSocket connection is made. We create a Vuetify app the same way we have been creating it before, however this is now done on the browser module and no longer on the pgindex module. We have a new module to keep the global reference to our app, so that we can use it when we creating other router pages. On our WebSocket Connect method, we initialize Vuetify, we create the schema of the app like before, we add routers, add the drawer and then serve our app. We also register the SQLite on browser method for our Vuetify project. This enables us to call it with run method. This method receives the payload to send to the server. This is converted to JSON, then we call the SQLite on server method, which is a promise. This promise returns the payload to be injected to the browser. We have created normal code modules for the other pages. We have used the same methodology we did before here. We however need to ensure that these are interpreted as Banano or browser pages, so we feed them a directive, with the region indicator. For each route, we have a Payload Manager, which handles the payloads received from the server. When we open our browser page, we can see an Add Drawer sub. This creates a tree-like list on our drawer. This has been discussed before and it's nothing new. Our View SQLite page is just a normal page we have created before. This has functionality to add, update, select, and delete records from a SQLite backend database. Our add method is using BananoServer class. This was discussed before in our tutorials. We use the class to build our query and then payload to the backend database. We however, this time add a callback method, which will be called and passed to the Payload Manager to process the payload received from the server. In each of the CRUD methods, we build the queries to execute, specify the callback method, then feed these to SQLite on browser. SQLite on browser will then feed these to SQLite on server. SQLite on server returns a payload and this gets fed to the Payload Manager. This then feeds our user interface. This is managed by the shared ODBC module which links the browser and the server. The browser and the server modules work in pairs. We have browser index and server index modules. The bond is the shared ODBC module. Let's run our BANanoServer application. This will be running on the local host on port 55056. The IDE log is updated with what is happening in the background, including the Java Jetty server. We open our browser and open localhost on 55056 and refresh it. Ensure you press and hold Shift and click the refresh button on the browser to see the latest changes. The pages are cached by default. We see the tree we created. The SQLite backend code is running on its own page. Let's go there. We add a couple of users. We execute some other queries like selects, deletes, updates and delete all. In each click, SQLite on browser is called with the payload. The payload is passed to SQLite on server. This returns a payload and we process this with the Payload Manager, and the Payload Manager helps to display the response on the user interface. We will open the underlying database and see the records soon. Let's open tutorial 44 and access the database. This will be on the assets folder of our directory. We open the www objects folder. This is the folder with the contents you will upload on your web server or VPS. When publishing, also the jar file should be uploaded on the server. We open the database. We add some records directly from our user interface. We refresh our select query and see our records. When we are done, we need to stop our server application. We can do this via the taskbar.